Hello, and thank you for joining me. You're here with data science teacher Brandon, and we're going to be talking about the logistic regression in scikit-learn. We're going to go into a little bit of detail about how to tune the discrimination threshold and how to really improve your score. A very easy way to improve not your accuracy, but either your precision or recall, depending on which area you're concerned about. Okay, so let's start off by importing our libraries here, our standard data science libraries. We're going to import from scikit-learn, logistic regression, train test lists, standard scalar, and fusion matrix accuracy and precision score. So precision score, just to keep it simple, we'll focus on that one versus the recall. But what we're going to do, it would apply to the recall score as well. So we're going to turn off when we use another library, the Yellowbrick library to do the visualizations, we're going to make a lot of warnings. So turn off inputting the Titanic dataset to do a binary classification for the survived dataset here. To keep this as simple as possible, we're just going to fill the null values with the median, one hot code of the categories, and then we're going to make the train test split, so making the features a list of the target, putting the features of X and Y, and then doing the train test split of X and Y to the train test. And then do the standardization of the X features, initializing it as I fit it at the same time, and then transforming it in the next two lines. How to do that? Yes, now our data is all ready. It's super simple data processing this time. And to get this ready, then what we're going to do is do a logistic regression right here. We fit our logistic regression score and score giving us an accuracy score. So 79 roughly to get started. And logistic prediction right here. And then what we see here, our precision score is 0.76 and 0.76 here. So let's see if we can play with it and tune that a little bit. Looking at our scores right here, we can see our precision score would be concerned about this top right corner. Out of their total predictions in the right one, how many times were we accurate? So they say how precise were our predictions. And so this is out of these two percentages right here, we're getting roughly 24% incorrect. And so then the log predictions right here, or sorry, our logistic regression predictions here, and then it's showing on the test set as well. The tuning and discrimination threshold right here, we're going to use the discrimination threshold function in Yellowbrick. So Yellowbrick.classifier discrimination threshold. Plotting, making a figure size, plotting initializing the discrimination threshold visualizer, fitting the visualizer. This will create the confidence intervals, fit it many times, and also why we turned off the warnings, because as doing this as it's generating the confidence intervals, it creates a lot of warnings. And here doing proof to show, the show version for the other longer. So what we're going to do is, as you can see, as you turn up the discrimination threshold, you're going to kind of sacrifice one for the other. So blue is the precision, and the red is the recall. So as you turn up the blue, as you turn up the discrimination threshold, you're going to improve your precision, right? How precise are you of your predictions, right? So that's going to be, the more sure I am, the better percentage I'm going to get on my precision. And so if I'm going to wait until I'm 80% sure to make a yes vote, then I'm going to be much more confident and be much likely better on average on my predictions. Vice versa, though, I would be making more errors on this side. So as I improve my precision, my recall decreases. So it's really a give and take relationship. You won't necessarily be able to instantly improve you might be able to slightly improve the overall accuracy, but it's usually pretty minor. But we will be able to highly improve our precision versus our recall, depending on what we choose to. So accuracy score here, we're going to do this, we're going to do prediction proby instead of just prediction. So we're going to then select out the predictions for the two columns are produced, or we're concerned about class one, so it's the second column. And here what we're going to do is we're going to set the threshold at 0.62. It produces true and false vector. To set that as just ones and zeros, we're going to multiply it by 1. And what we're going to do here, plotting the predictions for those here, our train test, train, and our test predictions. So you can see we're making less errors right here because we're specifically concerned about that. Let's see here. We're going to do our test scores right here. So our score it improved slightly, but not really. But where we really see an improvement is in the task precision score. We increased it usually, by a couple of points here. We could improve this threshold. We only slightly improved the threshold, from like 50 to 0.62. So only a slight improvement. We improved our overall accuracy just a little bit. But what we could do is maybe try 0.7. And I would expect this that you could do this very well, but you're going to start sacrificing as this red starts to drop your overall accuracy, your F1 score related to your overall accuracy. So it's fun. It depends on like an example of if you were to loan someone money and they pay you back and they don't pay you back versus if you don't loan someone money and you lose out on that profit. They're very different costs, real world costs. If you don't loan someone money, you could lose $100,000. Whereas not making a profit, you're making maybe 5%, $5,000 comparison. So you'd have to make 20 times as many correct decisions on one side to make up for loss on the other side. So maybe, and why getting a loan is so hard, their precision is their discrimination threshold has turned out to be quite large for that reason, because of the discrepancy in each type of area, the cost of each type of area. So play around with this, have fun, and I will see you next time.